You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Welcome back to the show, everyone. Hey, Kirk.
Hey, how's it going, Rachel?
Great. How about you?
You know, I'm doing really well, although I am just getting over some sort of plague that has been sweeping through our house and through the houses of everyone I know, pretty much. Maybe it was COVID, not sure, but it's sort of still, it's lingering a bit. So if I sound a little off, that's what's going on in my world. But otherwise, I'm actually feeling really great.
Well, that's good. I'm feeling pretty good. I'm feeling damp. It's really wet outside. Currently,
here as well.
Where I'm at.
There are thunderstorms rolling past me right now. So if, who knows, maybe we'll lose power right in the middle of this. That would be exciting.
That would be so fun and not at all tragic for us at all.
No.
So because of all the rain that we've been having, I'm going to be blunt. There's a couple, I'm just thinking about water, and water makes me think of the ocean. So of course I'm going to the ocean this week.
Rachel, like you needed an excuse.
I
to
don't,
talk about
but
the
to be
ocean.
fair,
That is preposterous.
I do try to spread it out a little bit, and
Fair
I did
enough.
count. It's been 5 episodes since I've talked about the ocean. So
I love that you're like counting, like, I can't go back to the ocean
wait,
yet.
Yeah, I gotta wait. This also came to fruition. This particular topic came to be because of a listener of ours and a Patreon member, Mary. Thanks, Mary. She texted me and she's like, dude, talk about this. I'm like, all right, you don't have to ask me twice.
Awesome. Thanks, Mary.
Yeah, Mary. So, Kirk, we've talked on the show before about jellyfish.
Oh, yeah.
Right? Yeah. We've talked about them in a couple different ways. We talked about Portuguese man of war. Victoria talked about the jellyfish that you can't even really see. I cannot pronounce how that jellyfish is named, so I'm not going to try.
Fair.
So we've talked about them a couple different times on the show. But there's so many different types of jellyfish. And they're all so unique in so many wonderful, amazing ways. But this one, why?
Just why, right?
Just why? Well, this week I am talking about this group of jellyfish called upside down jellyfish.
Ooh, okay.
Have you heard of these?
It rings the tiniest of bells.
Okay.
Tiny one.
Well, good. You did.
I'm not a jellyfish,
jellyfish
aficionado. So,
I mean, to be fair, this is at least the second jellyfish I've covered, and I think I covered that. I talked about this in an extra somewhere, but jellyfish are one of the things that I have respect for and never want to be near.
I mean, I've seen them from like a canoe in the Everglades and stuff. Very cool. I don't want to be swimming with them.
Exactly. I'm good. Now,
fair.
So when you think of jellyfish, generally speaking, their body shape, you think of a bell on top, like this rounded, like thin membrane, all of their organs and things, and then you have the tentacles that hang down. That's generally what you think of when it comes to a jellyfish. Well, an upside down jellyfish, turn it upside down. These jellyfish hang out in shallow reefs and in shallow areas of the ocean with their bell on the ocean floor, their tentacles going up.
Really?
Yes. So there's 8 species of these. It's a flattened bell, and they rest on the sediment. and they pulse a little bit to push water because they still eat zooplankton, but they also need oxygen because they are still a living creature, right?
Sure.
But they have their tentacles out, extending upwards, splayed out, and they actually have an algae that grows in their tissue and photosynthesizes. Kirk,
What?
this jellyfish farms.
Awesome.
It is
They're solar
farming its
powered?
own food.
Oh, I love when animals do this.
It is absolutely wild. So, like I said, they generally will stay in like shallow area because if they have algae that grows within their tentacles, they need to be able to get the right amount of sunlight. So generally,
Sure, yeah,
it's
they
less
can't be
than
like
3
super deep
feet.
or anything, right?
Yeah, it's like
Okay.
3 feet. So they're
There you go,
really
there you go.
sheltered coastal spaces, like not super deep, but they are definitely still in the ocean. So there we go. But because they need the amount of sunlight, but they are able to process some of the food, the energy that is created through photosynthesis by this. It's called, oh my gosh, zooxanthellae is the algae that grows in their tissues, and it actually gives them their color. Now, if I was a jellyfish, generally speaking, if I'm going to farm my own food and I'm pulsing water around me and I don't really have to move, I wouldn't move, but that's just me. But these can also move. They can shift and detach from the floor, the ocean floor, the sediment, and move to a different spot that's more favorable because they do also eat zooplankton. So they will still catch, and they are jellyfish, so they do have some like stinging type qualities.
So the whole being solar powered thing is sort of like an accessory to their survival rather than their main means of getting by.
It is still their main way that they get by. It's up to 90% of what they need for food. Wow. So it's still a lot. But
so they've almost gone all the way, but they still retain the ability to
eat other things. Yes.
Plankton and stuff.
Mm-hmm.
Wow. Okay, that's really mind blowing.
Isn't that wild? And like generally speaking, we know that they can swim, but it's just hasn't been seen much. Like I said, they do like to like me. They like being sedentary sometimes and just chilling.
But you're not solar powered. Last time
I am not, so I do move a lot.
Smart.
And these are just the this is just their adult form, the Medusa. So the Medusa is the adult form of a jellyfish.
Sure.
They are able to release reproductive cells and everything, and so what they'll do is they kind of, what's the word? I'm thinking the plant version of this, which is like sporing. Like they just release everything into the water, release their eggs. Eventually, the fertilized eggs will attach to some sort of hard substrate because they're often found in mangroves, so maybe a root, and then they'll become a polyp and then continue on. Once they are ready, they'll go through their process to become a Medusa.
Wow.
By
the way, can we pause for a second and just appreciate that the adult form of a jellyfish is called a Medusa?
It's so good.
That's fabulous. That's right up there. Top 10 naming conventions in nature.
They did an
really
excellent job
on that one.
And I'm going to be honest, I'm going to kind of pause on that front. I'm not going to go into it all that much more because truly jellyfish reproduction is a wild topic on its own. So I'm not going to go into all that much. Spoiler, I guess, for some future episode where I go into jellyfish.
How jellyfish get it on. That's going to be the title.
Well,
search for it in the future.
Well, their life cycle, not so much like how they get it on, but like
right. But
it's a much
more clickbaity title, you know.
Oh, absolutely, yeah.
Not that we would do that, you guys. We respect you so much.
We do, but also we will go for a clickbait.
I do like a good title because there's a lot of choices out there.
So good.
And you guys got to catch people's eye.
Yeah.
But I try to always be truthful.
Which I appreciate very much, and I know our listeners do as well. So
Good.
upside down jellyfish. That's what I've got. Their sting isn't really that bad, depending on how many of them sting you. They're not very large. They're generally they can be anywhere from 2 to 30 centimeters. So they're not huge.
Sure.
So there's just a lot of them in a clump. But that's what I have for you all this week.
Very
Upside down jellyfish.
Very nice.
My sources this week I had an article about them from the Australian Museum, as well as some Wikipedia, and Monterey Bay Aquarium had some great information, which was great. Okay, I just said great a lot.
Well, that was great, Rachel.
Oh, thanks, Kirk. Also, just for those of us who don't speak science, 30 centimeters is 16 inches. So a little over a foot. They can get big, but for the most part, they're pretty small. So
Cool.
Mm-hmm. All right. So we're going to take a quick break. And then, Kirk, I heard that you have a wild story for us.
I don't know if it's wild. It's big.
It's a big story. Ooh, big
Yep.
episode. Got it.
See
Exciting.
you soon. Before we get back to the show, Rachel, you know this already. We have the most amazing listeners, right?
Oh, absolutely.
And like I said, we
best.
can't read every message people send us on the show, but we try to read some of them to you guys. And I got an amazing message through the Podbean app. A lot of you guys listen through Podbean, and you can just right below the episode just type us a message right during the show. So it's really cool.
Love it.
We got one of those from Christy. Hi, Christy.
Hey, Christy.
And this message just really blew me away. She said, "Thanks for amusing my post-stroke brain. No doubt you're stimulating neurogenesis and neuroplasticity." So she's listening to our show as part of recovering from a stroke, which is astounding.
That's amazing.
Happy to have you as part of our audience, Christy, and to all of you as well. It's so amazing to hear the stories of the people who listen and why you guys listen and what you like about it. It brightens our day, and we're happy to know that we are a part of people's lives like this. That's really an amazing, sort of mind-blowing thing.
Oh, absolutely. Thank you all so much for listening. You all are one of the reasons why we do this show.
Absolutely. Yeah. Contact us through the Podbean app, through social media, our email address, contact@strangebynaturepodcast.com. We love hearing from you. And we're going to get back to the show. Okay, Rachel. This week, I want to start off by talking about the Heliosphere. Does that ring a bell to you at all? The Heliosphere?
Well, I know Helio is sun.
Very good.
I feel like it has something to do. Helio. Is it a part of the atmosphere?
I mean, kind
like
of.
a layer?
In a way,
It's like
if
a
you're talking
layer
about
in
the
the atmosphere?
sun, not so much us, but about the actual sun. So you had it right. It's
Okay.
helio meaning sun and sphere meaning sphere, big round thing.
Right.
In some
cool.
ways, the heliosphere is hard to understand as it is invisible and it's in space.
Right. Okay.
So it isn't something we can ever get to observe or interact with in our day-to-day life.
How do we know it's there?
Well, that's a great question. We can measure it. But I think for a lot of us, it seems kind of irrelevant because we're like, unless you're, specifically working on studying something like this, you're not going to really encounter this in your day-to-day life, right? Now,
Right.
many of our listeners, no doubt, though, saw the northern or southern lights this spring when we had this huge coronal mass ejection, the CME,
Yeah.
that was on a direct course for Earth. I mean, those were some of the most amazing aurora ever. Actually, where I was,
so cool.
they were actually a little bit disappointing, and I'm about
There was just so much.
Yeah, it was too much because I'm at the 45th parallel, almost exactly. So I'm halfway between the North Pole and the equator. The northern lights were so intense that the entire sky was glowing green, and it was glowing so much that this dull glow was washing out the brighter colored parts of the aurora. So you're like, oh yeah, no,
that's kind of what
I
we
kind of see it, but it was just
up this far.
yeah, and you were in further
too.
north, so it's probably even worse for you guys. It was
it
was
was
nuts.
it was very bright, but it was the whole sky.
yeah. So these were the result of particles, charged particles that were coming off the sun. Now, when a CME hits us, that's like a big deal, but the sun is constantly emitting particles in all directions, either from these big mass ejection events, but also just like sort of just background noise, just in all directions, is blowing this stuff out. These charged particles are blasted out at supersonic speeds, and we call this the solar wind. So the simplest way to think about what the heliosphere is that this is a bubble in space that's caused by the wind that's blowing away from the sun and just pushing stuff out of the way. Does that make sense?
It
Insofar as
does.
it can.
Yeah.
Yeah.
Like, I guess it does. Sure.
Well, so we're gonna go into this, okay? Because it's really bizarre and interesting, and there's some cool stuff.
Well, the fact that like there's like a bubble in space is caused by solar wind, which is caused by the sun just emitting a bunch of particles.
Which are like the ripped apart nuclei of atoms and stuff, but we don't need to go into all that.
Right.
It is, it's,
my head hurts.
I could have done an episode on just what the solar wind is because it's so weird, but just note there's all these particles shooting off the sun and they are going supersonic speeds. So they kind of blast things out of their way, and it's not like a super strong force, but it's one of the more dominant forces sort of like going on out there in space that's affecting kind of what's happening in our local area.
Right.
And so I said it's going supersonic, right? There's not really anything to stop it or slow it down. So it goes...
Right. Well, I mean, like, there's like... That's the whole thing about space, is there's not really...
It's mostly empty.
Yeah.
So it does this. It goes at this speed, this wind really blowing for an incredible distance. It does, though, eventually encounter an area called the termination shock, where basically it runs into the interstellar plasma, which is basically like the mostly empty space between stars. But there's little particles and stuff in there, and eventually our solar wind kind of smashes into that. Or I like to think of it as like it runs out of enough juice to keep pushing it away. They collide, and you get this sort of bow shock area of this termination shock. And this occurs really far away, okay? This is way out past the orbit of Pluto where this termination shock happens. But that's not the end of the wind and whatnot, and the end of the bubble. That's just where it slows down so it's no longer supersonic. So it's going supersonic until it's past Pluto. And then it kind of slows down.
I mean, if you're going supersonic, you're gonna be that's really, really fast.
I mean, like we can make airplanes go supersonic, but they slow down really fast if you stop. Like turn off the engines, because our atmosphere is really thick. Even the interstellar plasma that it runs into is incredibly thin. Like there's not much out there, but it does eventually is enough to kind of like slow it down and eventually stop it. So, as it gets slower and slower, eventually reach the edge of the heliosphere where the solar wind like runs out of steam and reaches a balance with this interstellar medium. And I think the wind analogy actually works really well here. Like the wind is blowing like mad near the sun. And by the time you get out past Pluto, it's kind of slowing down. And at a certain point, you kind of have to draw a line and say, like past this point, we just really can't detect it anymore. And we call that line the heliopause, the sun pause. It kind of
what a great name.
Yeah. So
like I understand it means pause, like you pressed pause.
Yeah.
But when you first said it, I immediately was like, sun pause, like cat pause or dog pause.
Weird. That's weird, but I'm here for it. The Voyager 1 spacecraft, right? It actually passed the heliopause, and we could measure it with instruments back in 2012. And Voyager 2 passed it in 2018. So both of these spacecraft are now in interstellar space, which is very cool. Measurements between the two craft actually varied a little bit on like where this line was, but they're also headed in different directions, and it's not like a perfect circle. So we can say it's like somewhere between 120 and 130 astronomical units away from the sun. And you're going, okay, Kirk, you're getting deep nerd here. What is an astronomical unit? Okay, an astronomical unit. Do you know it?
Vaguely remember this.
Do you know what it is?
I've heard of it. I remember it. I don't
It
remember
is the distance
details.
between two really important objects.
The Earth and the Sun.
Yeah, that's one AU or one astronomical unit.
Yeah.
So here's the thing. The heliopause is like 120, 130 times further away from the sun than the Earth is. That's really, really
that's very far.
For reference, Pluto, like that really, really furthest away thing we think about, is only 39 and a half astronomical units away. This is like 130. So the solar wind and the heliosphere is freaking huge, right? It's so big. So basically, okay, you got this thing called the heliosphere. It's a giant bubble of wind around the sun. Like, so what, right? Well, it turns out it's really super important. Space is a pretty nasty place. The solar wind is actually kind of nasty too, but it's less nasty than what's in interstellar plasma. Namely, we're talking about radiation. You have a lot of radioactive elements floating around out there in space, partially because you have a lot of like supernovas and things that have gone off that have exploded stars, and you create that's how you create radioactive elements, is in the heart of those supernovas. So there's a lot of radiation out there, and actually the solar wind basically pushes not all, but a lot of that away and keeps the Earth kind of protected from a lot of this radiation.
That's good.
Now, as you may know, if you talk about space at all, when astronauts go up in space, there's still a lot of radiation in space, but it would be way, way higher if it wasn't for the heliosphere, which is very cool. And I did hint at this, but the heliosphere isn't a perfect bubble. Like it's shaped more like a teardrop or like a comet. And the reason for this is that this is sort of mind blowing, but our solar system isn't sitting still. It is traveling through space, orbiting around the center of the Milky Way. Like our entire solar system, our sun is moving and we're moving with it around the center of the Milky Way at 228,000 kilometers per hour. That's how fast we're plowing through space. Now, it doesn't feel like that, right? Because the whole solar system moves as one big unit. It's kind of like how if you're on a train going at high speed, everything inside the train seems to be at a standstill. Like if you set your glass down, it doesn't go like flying, to the back of the train at 100 miles an hour. It's like, no, we're all moving together. So it doesn't feel like we're moving that fast, but we know that we are, as a solar system, moving at 828,000 kilometers an hour. And when you're traveling so fast, we're traveling through the interstellar plasma and it pushes back some. And so the bubble gets kind of squished up front in the direction we're traveling and drawn out like a tail behind us. But again, it's huge. So like, everything in our sort of solar system, like all the planets and stuff, are still within that bubble, even though it's kind of squished. Well, a paper just came out in June of 2024 that asked an interesting question about what would happen if we were to encounter something in space that was denser than this mostly empty space we're traveling through right now. And because a lot of space, it's empty, but it's not super empty. There are these huge clouds or ribbons of cold hydrogen gas out there. Some of these are actually the clouds that eventually collapse into new stars. They're not super dense, but they are denser and colder than the sort of the general empty space that we're plowing through right now. And what's interesting about this paper that came out is it suggests that we actually did pass through one of these clouds in the fairly recent past. So this is only possible because there's some really new computer models out and we're getting more and more and more data about exactly where things are in space and how far away they are and what direction we're traveling, which allows us to kind of wind the clock backwards and ask, well, okay, where were things in the past? Which is
Right.
super, super cool. And when they did one of these models, they looked at this one particular ribbon of this cold gas. They figured out that the sun, the whole solar system, probably passed through one of these clouds about 2 million years ago. And
What?
the researchers actually believe that this region was dense enough that it basically collapsed the heliosphere down so much that for almost 2 million years, Earth was outside the bubble. We were outside the
What?
heliosphere because it got so, imagine this big kind of bubble, and then you hit this denser stuff and it kind of blows it away and it becomes this very thin, jet stream of solar wind blowing off, as opposed to kind of going in all directions. It's all being funneled in one kind of jet in one direction, the direction we're traveling. And we were not in that stream. I mean, we may be like pass through it once a year or something like that, but for the most part, they believe we were not in that. Or maybe it couldn't be that it was
What?
blowing, like up out of the plane that we're traveling in, like the plane the planet's spinning. So basically, they think we were outside of this protective bubble for a long, long time. And that in and of itself
Whoa.
is really cool.
Yeah.
But what's really interesting is that when we want to you go, okay, but like, is there any, like a computer model suggested that's where things were? Is there any evidence, like hard evidence of this that we can like correlate this with something? Well,
Right.
when we take ice core samples, like in the Antarctic, we can actually find ice that is millions of years old. And you can actually look for the different radioactive isotopes that are in that ice. And sure enough, researchers have found that about 2 million years ago, there was several different radioactive isotopes that spiked up, and the Earth started to get
Whoa.
a whole lot more of those accumulated in the ice. And we don't like make new radioactive isotopes on Earth. I guess we kind of do now, like if we're, having a nuclear reactor or something like that. But generally in nature, they're very uniform in the amounts we get. And so when you see a spike up like this, it's like, well, something happened here.
What did you do? What happened?
Well, there'd been different speculation in the past, like what could have caused this. One of them was that there could have been a supernova nearby the Earth, but that was always kind of troubled people because you're like, well, it'd have to be really close for us to get this influx of stuff. And if it's really close, it's also going to like probably destroy the Earth. So it's this.
There's going to be other things happening.
It's this really tiny window of like being close enough to like deposit stuff on Earth, but not so close that you just like wipe out everything in our solar system. So people didn't really like that explanation, and we may now have a new explanation for why there's this weird spike in some of these radioactive isotopes in really ancient ice. Now, the other thing, and this is part of speculation, but I think it's really interesting. When I said that we entered into this cloud that blew away the heliosphere 2 million years ago, does that number 2 million years ago ring any bells for you, Rachel? What else happened on Earth 2 million years ago?
65.
Carry the 2, add 4.
Carry 3.
Can you think of what was going on? I know you weren't here for it.
No, I wasn't. Was that the beginning of the Ice Age?
Bingo. Absolutely.
Yes!
It was the beginning of the Ice Age. Now, I don't know if we have
I can keep my naturalist card.
a specific mechanism for this, is for speculation, but it's a really interesting coincidence when you go, okay. So could us passing through this cold, gas in space that blows away the heliosphere, kind of is changing the local weather, if you will, out in space, could that affect something like an ice age on Earth? We don't know. Was it one contributing factor? So it happened to fall at the same time the sun was going into a quieter phase. Like there's all these different reasons that could be going on, but it's pretty fascinating. So I think what some researchers are now hoping to do is to model where other ribbons of clouds of this cold, dense hydrogen used to be, and then compared to where the Earth also would have been, and have we encountered any other ones, and do any other ice ages on Earth besides the most recent one also line up with something like that? If they don't, then
Yeah.
we kind of go, well, that was just a coincidence. But if they do line up, then you start to go, okay, like this
Well,
is
then.
pretty wild. It blows my mind that
Yeah.
like there are these things going on that are so big giant picture things in the scale of the entire solar system of the universe are actually affecting something like on Earth like that.
Mm-hmm.
And the authors of this paper did also point out that climate change 2 million years ago is thought by some to have been a driving factor in the evolution of modern humans because they had to adapt to this new climate. So the Earth encountering a cloud in space could actually be a factor in human evolution, which is like mind-blowing. So cool.
That's wild.
And I think sometimes people go like, well, why do we care? Why do you care about space? You know, these things happen way out there. And, you know, it's why I like to talk about space on the show is it informs our lives, you know, and it could actually even be affecting our lives. So we are part of a giant cosmos that created and affects us. And I think it's a really beautiful and just amazing thing. I will also add, I think big picture, one of the things that amazes me is how much our science is informed by our current state. Like if we happen to come of age as a species while we were inside of one of these dense clouds and the heliosphere wasn't protecting us, would we think that that was the normal state of things? Right?
I mean, yeah.
Probably for a while until we knew had studied more. And that I think it's just so cool that like it brings the question of what other confounding factors are at play at this very moment that are affecting our science because we're doing the science right now. Indeed, we are currently traversing the local interstellar cloud in space, and we have been for thousands of years. Is that having any effect on us? I don't know. The cool thing is that we can have the answers to this because the smarter we get, the more data we have, the better we can answer questions like that. And I think it's just a really fun mental exercise, though, to think about like, what things are we only viewing the way we do because we are alive right now?
Right.
Which is cool. And I guess the only way we can figure that out maybe is just by keep on looking out there and keeping on figuring out the answers. And I guess those computer models help a lot too, figure these things out. So I thought that paper was super cool. That's why I wanted to talk about it this week. It was in very recently, like I said, in I think June, kind of mid-June, came out in the Nature Astronomy. And it was called A Possible Direct Exposure of the Earth to the Cold, Dense Interstellar Medium 2 to 3 million years ago by Ophir, Loeb, and Peak. So thanks to them for writing that and doing that research. Awesome. And that's what we got this week.
Amazing.
We went from the jellyfish in the ocean to the giant interstellar clouds. So I think we covered it all.
We went from the ocean floor to past Pluto.
I think we covered it all.
I think so.
Awesome. Thank you so much, everybody, and everybody just have a great week. See you next time.
Yeah. Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.